Okay, in this tutorial, I'm going to show you how to use Houdini to generate a tiling texture um, of cables, like kind of like a cable bundle texture. Um, so I'll just kind of like walk you through what I have here. Let's turn off some of these things. Um, So first thing, we set up a render target. The render target is just a grid. In this case, I'm not making it square because my end goal will be like a kind of a strip, like a tiling strip texture, but you could make this square. Important thing is to then UV it. And so if we see, this is the UVs here. So you get that UV'd. You can always do a UV quick shade node to check your UVs. And then I just have a little out node. And up in here, I set this, just FYI, I set this to display as a bounding box, just so I know that it's my like render target. And then the real meat of this is the cables and how you generate these in such a way that they're tiling. So we'll take a look in here and walk through this. So first thing I do is I get my render target because I want to start with the same size. I add a bound to it just so that, and this bound you see just gives it some thickness because it has a minimum size here. And so this bound is like really handy to just kind of thicken something up, like a plane like that up. I transform a little bit just because I found that like without the transform, basically the idea is you're going to be generating two sets of points here, like start points and end points, where you want the cables to run. And I found that if I didn't have this transform, then you'd end up with this bundle of wires mostly in the center, and you wouldn't of the tiling texture, but we'll come back to that. So yeah, after you generate the bounds, I just blast everything except for an end, scatter points on the end. We'll come back to this. Then do a start group and an end group and move the end group. I moved it 1 because that matches the, let's see if we show the, so this is the render target you can see here. So I just moved the points to the other end of what we're going to render here. Can come back to this. Then what you want to do is, so you merge your start and end points. Make this a little bigger. Then what you want to do is connect adjacent pieces, and I just kind of set these high just to make sure that I was getting the connections across. I guess like this, like 5 is probably fine, but it doesn't really matter. It's basically connecting all of them, and you want to set this to adjacent points, to connect adjacent pieces. Then you want to do this find shortest path. It seems like a roundabout way because you think like, well, couldn't we just, extrude these? But I'll show you why this approach is kind of nice later. Yeah, so find shortest path, and I'm doing from each start to corresponding end. If you do, yeah, from each start to corresponding end. And so it's just saying from from each of these points to each of these other points. And then resampling so that we get more little points in here. We turn up the, is there a point size? Point size, here we go. Should work, I would think. That's particles, I guess. Oh, hopefully you can see these points. Because I don't know how to make them bigger right now. Yeah, so we got these points here. So we just resampled our lines, and then I'm just copying the start and end groups back. I don't end up using them later though anyway, but yeah. Anyway, midpoints. So this group, I use the resample one. You can turn this on and output the curve U. And then using that, I make a group of all the middle points. So all the points that aren't 1 or 0. And these could be equals instead, but whatever. Then what you can do is you can do a mountain, which is basically like a noise, and you set it to act on all of the midpoints. So using this, you can basically kind of shuffle them around here. Then what you want to do is you want to copy. So I made this into a little subnetwork, but all it does basically is takes this. I group it as a center group just in case I wanted to like be able to access this middle group again. But yeah, then you copy it to the left and to the right and the left based on the render target size. Merge them together, fuse them, and that's so that you fuse these little points, the little endpoints together. And then I delete the center group so that these don't get the center group. And then duplicate it up and down. And you want that to be the same distance as your like render target. So this render target grid size originally was 0.25 across, and so I moved them by 0.25. And then merge them. And you can see then I kept this like center group here. That's just the middle one part, but there's maybe a more elegant way to do this, but I did this way. I exposed these, so these are just this is just the bounds basically that I exposed here. So if you wanted to change that. Now that we have them duplicated around and we have them fused, which is a really important part, we can subdivide them. And you can see if you don't fuse them, when you subdivide them, you'll get these like spiky points, and your tubes will kind of like lose continuity. Here I can drop a wire node down so you can see what they're looking like. so you see like without the fuse, and then if we go back in here and turn the fuse back on, it's a little smoother. And because you copied them both to the left and right, they should be mirroring perfectly right now. And actually, let's go ahead and this will be a good point to move over to like how to render this. So I'm just going to leave this set up here with my wire. And I got my render target and my cables. And one important thing you'll want to do is, and I'll walk through how to do this, is you notice the render target is somewhere buried in the middle now. So what I like to do is axis, there's this really handy node, axis align, which is normally great. It like moves everything by default. It sets the object like on the grid and centers it. It's part of the game development toolset. If you don't have that, you open up your game development toolset tab up here and you say update toolset, and it'll give you all this stuff. Super awesome that Side Effects does this. Yeah, so in order to, we want this to be below the grid because our render target's on the grid. So we're going to go over here, set this to max, and then we don't want to change it in the other direction. So that will fix that. And now if we go and we go into our, you can see change context to the output context. You can set up this texture baker. And you'll find this by just doing bake texture. We can just set up a new one. And UV object, you want this to be your render target. Your high res object, you want this to be your cables. And then for this, I'm just going to remove this, the hip name part. So it's going to use this $sign OS means it will take whatever name this is. So we'll call this bake cable bake demo. It's kind of long. Cable demo. Help if I can spell. Okay. This is UDIM stuff. I take that off. We don't really need that. Channel, that'll be helpful. That basically uses whatever little code you see here will be the name of the channel. So for this we want tangents. Let's make this PNG. Then we're going to do tangent space normal. We want that one. And let's do occlusion for now. You can do a bunch of others also, but just for this demonstration, let's do those two. And advanced rendering, blah, blah. I think that should be everything we need then. You got your resolution here. We'll just do 1024 for now. And then if you say now if you hit render to disk, in a little bit you should see should be able to open up there's some like render manager in here somewhere. Scheduler, yeah, there we go. You'll see it appear in here. Yeah, here we go, cable demo. I can clear completed. So this is really handy to see when you fire off these that don't appear anywhere. So now if I go into my maps, we should be able to find it in here. Cable demo. So we got this. You see these like streaks? This is actually from the wire SOP. So we can refine that later. But you see we got the normal and the ambient occlusion. And then the really handy thing is you just, whenever you update this, you come back, hit render to texture. It's going again. Okay, let's go back to the objects. Oh, and if you see how I switch between those, so you hit Control. If you hit Control 1, you set a quick mark, and you see it up here. That means you can jump back to this context anytime. And so I usually set my rendering to Control 3. And it'll actually switch back to whatever node you had selected then. So you can see it switches back to that node being selected. Anyway, let's continue with, so one problem you see is, it's not super apparent here, but, well, so yeah, one thing we can do that's kind of neat is, see how all of these pieces are just connected like straight across? What we can actually do is we could have wires, go from one input to another output, and that will still tile because we still have the same positions of inputs and exits. So the way I went about doing that is I came up here before we had copied the points to the other side, and I did attribute randomize, and I just gave all of and I set this to custom discrete, meaning it's only going to give them whatever values we put in here, and you can make a whole bunch of values if you want, but we just need 2 because we're going to group based on this. So I did a value of 0, a value of 1, weight of 0.3, and actually let's copy this parameter and paste relative reference, and we'll do 1 minus this. So you can see that that'll be 0.7, and now whenever I increase this one, it'll decrease that one. But anyway, so 0.3 means we're giving about 30% of them a value of 1. And you can see this down if you look at your geometry spreadsheet, which is super handy. I call this connect rand, and you can see we've got a mix of 0s and 1s. And then we duplicate this. We do our duplicate to the other end, and now these points will have matching random or not random. Now what we can do is we can group them based on that attribute. So do a little vex expression here, connect random. If connect random is greater than 0.5, then put them in this group. And we can see that group here. Oh yeah, here we go, points. So you can see connect random. It's not really highlighting, I guess, very well. Here we go. Yeah, there we go. So you can see all these little red points they're in that random group. And so as we increase or decrease the slider, we get more and more random points. And so what we're going to do with those random points is, let's put this back to 0.3 so we don't get all of them, is we're going to split them based on their group. So this just takes this connect random, splits them out so you can see we only got the random ones now. Then we're going to randomly change their point order for these ones that we split out. And the reason why this is important is if we, so say we just take all of them and we randomly change their point order, what we will get is when we find shortest path, when it's selected from each start to corresponding end, they will randomly connect. So what we want to do is we're going to have some of them randomly connect. Let's put this back together. And to do that, we're splitting our group out. We're randomizing these. Then when we merge them back with our straight ones, we get a mix of these crossed ones and straight ones. And we can increase this if we want more crossed ones or less crossed ones. Yeah, really handy, I think. Oh yeah, another thing I was setting up, and I'll finish this here, is in this attribute randomize, you have this global seed, and this changes, like the randomization seed. I moved that out into a control, and so you can see here, so I move this, changes the seed. And actually I'll add another control here for, go ahead and modify the interface, and we'll call this random this from a range of 0 to 1. And then what I can do is copy parameter and paste that over here. Paste relative reference. And now I'll be able to modify that from here, as well as the seed. It's pretty useful. So yeah, so now you can see we've got some crossed ones. We do our resample. We take out our midpoints so that we can give them some noise. We subdivide them. Let's subdivide them one more time. Turn off that. And then we do our axis align and our render. So now we're getting some pretty neat tubes, and you can see the result of this sort. So if you keep it off, then they're all straight. Have it on, you get some of these that cross over, and that should all still tile perfectly, pretty much. The other thing you can do is you can see here there's some that are really intermingling here. Actually, let me just change to a poly wire. So the poly wire, the wire versus the poly wire, the wire seems to just kind of, I don't know, it doesn't look as nice. I'm not exactly sure what it's doing under the hood, but it's not making real polygons. It's making these like metaball things, you can see, and poly wire will give us a little better result here. What size did I have? 5, there we go. And you can see it's making actual real polygons. But what you can really see now is we have a lot of these like intersections. It's interesting. You see them here too, but the poly wire definitely makes them more apparent. And the poly wire will actually render a little nicer anyway. So the way we get rid of the intersections is this like handy tip that I got from some other tutorial. I forget the name of it. It was from Enigma or something like that. One of those awesome tutorial sites. Is we can run a detangle. And what you can do is put it in this for loop with feedback. And this allows you to run something over and over again, like through another number of iterations. And so that's what I set up here, detangle. And you want to, let's set up like a thickness on our controls here so that we have like a consistent thickness across them all. Or, nah, wait, we won't do that right now. But anyway, you want to, you want this thickness number to be about the same as you use in your polywire, because that's the thickness that it's thinking that they are. So we'll set this to 6, so it's the same. And now you can see if we run it through that, I kind of make it a mess. And partly, oh yeah, and before you run through the detangle, you want to put this like rest thing on it. I think partly that's, we have it subdivided too much. It seems to work better if you don't subdivide it too much before you run it through the detangle, because otherwise you get, you can see here, like if we subdivide this more, it starts like bunching them up too much. I think ideally even you might want to be, you subdivide it a little bit before and then you subdivide afterwards. So you let it do its detangle thing. And then I'm going to do another, and you can see I kind of like started doing it down here. We'll just move down here and use these. This attribute delete, I just deleted a bunch of attributes that I wasn't using anymore. And so you can see I subdivided again. And this, the detangle like helps quite a bit. I'm running it like 50 times. You can see it's getting a lot smoother. And if we turn that off, you can see you get all those intersections back again. Turn it on. Beautiful. One thing is, this might, hopefully this is like, this should keep the tiling pretty well, but it probably isn't doing it exactly. And there's a way we can, I think, fix that afterwards to get our tiling back perfect. But let's see how this is looking first. And I'll just walk you through, like, so I just add a normal, because it wasn't really necessary, but do the line thing, so it's under that. And then the other thing I do is, see there's some gaps in here, and we kind of had that with our ambient occlusion one here. See, this is a gap that rendered through, and you get some weird seams then. Assuming you're not, I mean, you could do render an alpha with this so that you have like actual cutouts, but assuming you're not doing that, what we can do, I find like works pretty well, is you just do a quick bounce on the whole thing, blast everything but the bottom, reverse it, normal that one also, and then merge it back, and now you have a nice little floor that is down there to catch any rays that go down there. This one's a little extra low because we're getting some pokey outy things. But yeah, anyway, let's see how this renders again then. Anyway, okay, so we got this now. Oh. Looks a little extra wiggly because of our aspect ratio, but I think it will look good in game. And actually, we'll show you how to preview this. So I set up this little thing, this little shader viewer. And if you jump in here, this is just a tube because I intend to like kind of use this as a texture to wrap around tubes. Okay, yeah, so get this UV'd. Then what you can do, give it a little normal, is set up this quick material. And just point this to, I put this on the PBR, and point that to your normal map and your occlusion map or whatever maps you're rendering out. And set your UV scale appropriately, like, and you can see it's looking pretty good, I think. Okay, so I rendered out one more so you guys can see it. And another quick tip is if you go up here, you can go up to render and update textures, and it will update the textures. So if you've re-rendered them, or viewing textures. So you can see here tiling, it's tiling pretty well. And then you can also see it here on this tube. And then I also put it on a kind of spline so you could see it, like how it might really be used in a game engine. I hope that was useful. Let me know. Bye.